Today, I'm going to talk to you about script R. R. Right, okay, so what the crap is script R? What? All right, so when I took Physics 2 and I was studying how electric fields work, I often got nice, happy problems where I would have a line of charges and I would be asked, what's the electric field at some point? Right, I could easily identify where the origin was and solve the problem very quickly. And that's great. But we want to start generalizing. And in fact, the farther we go in physics, we start rehashing a lot of the same problems that we're working on, but we get into it in a deeper depth, right? We're going to dive into this a little bit deeper. We're going to generalize the distance between atoms, or the distance between charges, in a little bit clearer way, right? And of course, the mathematics gets a little nasty. All right, so imagine that I have a charge. Hey, I'm charged, right? I got charges right there. And then imagine I have a test charge. Okay, so if I want to calculate the electric field between them, I need to know the distance between these 2 points. No problem. Except, what happens if I choose my origin here? So if I choose my origin there, now I got kind of a complicated problem, right? So what I care about is this distance, right? This is the value of, this is the script R distance that I need to calculate the electric field between this guy and that guy, right? But my origin is there. So I might have two separate vectors. I have the distance from the origin to this point. I'm going to call it R prime, right? And then I have the distance from the origin to this point. I'm going to call it R, right? And we know what R is, right? R is the traditional vector. So R prime is equal to x prime I hat plus y prime j hat plus z prime k hat. And the R vector is equal to x I hat plus y j hat plus z k hat. No primes, primes. Okay, so ultimately, we're going to be using this expression, these terms, with the following integral. The electric field is equal to 1 over 4 pi epsilon naught, the integral of rho, x prime, y prime, z prime, over script r squared, script r squared, script r hat, d volume prime. Right? So what I'm going to do is I'm going to integrate over my charge distribution, which is here. So I'm going to integrate over the location of these charges over the prime coordinates so that my final answer doesn't have any primes in it. We're integrating them out, right? We're doing a definite integral, so there won't actually be any prime coordinates in our answer. They're going to go bye-bye. But we got to account for the fact that they're there, right? And so what we care about is this thing, script R, right? So script R vector is going to be equal to R vector minus R vector prime. Okay, so basically, what I'm going to do is I'm going to have a vector which starts here, right, and points. So the script R vector points this way, right? Which is just the difference between this guy, right, subtracted out of the minus R hat. So you get this nice vector subtraction between the two, right? So let's think about that over here, right? If I have this vector, right, and I want to subtract, right, I take this line here, but I make it opposite. So I do head to tail, I go down like this, right? And then this is minus R prime, and then I just add those vectors like they're normal, right? So R plus a minus R prime gives me the following vector, which is script R, right? So this vector and that vector are the same vector, right? And it's R minus R prime. Now this isn't terrible this isn't a terrible vector to figure out, because you can just group the i's, the j's, and the k's and get the following expression: x minus x prime I hat plus y minus y prime j hat plus z minus z prime k hat. That's not terrible, right? So you have all the variables in there. And of course, if I take the dot product with itself, right, or I square it, right, so only the I hat dot I hat terms are going to survive, j hat dot j hat and k hat dot k hat. So this becomes x prime squared plus y minus y prime squared plus z minus z prime squared. Okay. But what we often need, which is a problem, is we can get this. This is important, right? And but what we often need is script R hat. And that's a pain. A real pain. So it's easier to sometimes think about it in the following way. Script R vector, right, is equal to the magnitude of script R times the direction of script R.
Hey,
Hi, John.
how's it going?
That was John Dewar, everybody. So what we can do here, since this is really just a magnitude of a vector, it's a scalar, we can divide out by it. And we get that script R hat is equal to script R vector over script R. So many times it's actually easier, if we want to find this, to find script R vector and the magnitude of script R, which we can find by doing these two methods and taking them and plugging them in, rather than trying to figure out what script R hat is in some other convoluted geometric way.